The engineering sequence is a methodical series of design steps that engineers follow to create functional products and processes. Each stage in this sequence follows a highly iterative process. The sequence shown in the picture represents typical engineering stages in an industrial project. This definition is not rigid. It must be adapted to the specific needs of each project. Sometimes stages overlap, combine, or may be even skipped. Now, let's dive into the content of each stage. Conceptual engineering, also known as front-end engineering design, FEED, or front-end loading, FEL. It is a first step in establishing the ground rules of a particular design. As shown in the picture, conceptual engineering typically occurs before the EPC contract. In other words, it is not part of the engineering activity within the main contract. Conceptual engineering tasks represent a set of preliminary studies necessary to develop the basic engineering design. These studies often consolidate engineering packages initiated by external process licensors, using standard process information as a starting point for the industrial plant. This phase includes strong planning and design efforts early in the project's life cycle, when design changes are still relatively inexpensive and easy to implement. A common industry practice is to divide front-end loading into three stages: FEL 1, FEL 2, and FEL 3, each with standardized deliverables. As previously mentioned, once the conceptual engineering phase is complete, along with all associated preliminary studies, there is enough information to decide whether to proceed with the project or not. Basic engineering bridges the gap between conceptual engineering and detail engineering. In this phase, the overall system configuration is defined along with schematics, diagrams, and design documents that establish the project initial framework. The main goal is to set up the general structure for project execution. Basic engineering can be seen as the collection of documents that define the project without any doubt. A key aspect at this stage is determining the industrial process around which the entire plant will be built. In some cases, the project owner holds the process know-how. In others, this know-how may be provided by an engineering company, equipment manufacturer, or a specialized licensor who owns the patented process technology. Regardless of who develops the basic process engineering, this information is typically compiled into a document known as the process book, black book, process package, or simply basic process engineering book. Its content varies significantly depending on the project. We see in this list the most common documents produced during the basic engineering stage. One of the most critical documents produced in this stage are the piping and instrumentation diagrams, P&IDs. They play a fundamental role in transitioning to detail engineering, particularly for the discipline of piping engineering. Moving on to detail engineering, in this stage where designs and technical specifications are developed with the level of detail required for construction and commissioning of an industrial plant. The image shows a 3D model created during basic engineering on the left, compared with the same 3D model after detailed engineering on the right. This example highlights the significant increase in detail that occurs in this stage compared to the basic or conceptual engineering. As mentioned earlier, the standard engineering sequence is conceptual, basic, and detailed engineering, followed by the start of construction. However, due to schedule pressures, it is becoming increasingly common to start detailed engineering before basic engineering is fully approved. This means working with unconsolidated information that is subject to changes, which inevitably affects the development of detailed engineering. Similarly, construction activities are often started before detailed engineering is fully completed. Another growing trend concerns the final investment decision. Instead of making the FID after completing basic engineering, some projects split detailed engineering in two stages, completing about 20% of the work first. This allows for more accurate cost estimates and more precise economic feasibility analysis before fully committing to the project. To develop the detailed engineering, the engineering manager or project director assigns specific plant units to different project engineers. These engineers must coordinate technical aspects across multiple disciplines. The work of each discipline is highly interdependent, as the output from one serves as input for another. Based on budget estimates, the project director allocates specialist hours to each discipline and support area, defining how much effort is expected from the different engineering disciplines for each plant module. During detail engineering, it is common for resident engineers representing the owner to join the project. Their roles may include acting as liaisons with the industrial complex, validating design criteria, monitoring schedules and budgets, approving specific documents, etc. Detailed engineering technical deliverables, as the name suggests, are numerous, extensive, and highly detailed. We are not going to repeat here the extensive list that was already made in the study notes. Suffice it to mention that it includes final and detailed versions of all the documents developed during this stage. In summary, by the end of the detailed engineering phase, the project will have fully developed designs and technical specifications, sufficient detail for procurement, readiness for construction and assembly, and all the necessary information for plant operation and maintenance. The final step in preparing the engineering package is the set of documents related to plant commissioning and startup. This documentation is crucial to ensure that systems, equipment, and process operate safely, efficiently, and according to the design. The information generated for the startup can be categorized as technical documents such as final as-built drawings, electrical drawings, equipment datasheets, etc. Testing and verification documents such as commissioning protocols, checklists, midterm test registration, etc. Operational documents, including operation manuals, startup shutdown procedures, etc. Safety-related documents, for example, emergency response plans, safety training records, etc. Maintenance documentation, such as critical spare parts inventory, preventive maintenance schedules, predictive maintenance. And finally, legal and contractual documents, like licenses and warranties. In parallel to all these categories, change management documentation is generated, recording physical or procedural modifications made during construction, commissioning, or operational phases. Engineering products, such as drawings, documents, 3D models, must undergo review and validation processes. These reviews may be conducted internally or externally. In EPC projects, the following 4 document releases are typically used. Issued for approval. This version allows all relevant parties to review and comment on the document. It must be signed at least by the developer and the section leader. Issue for design. Once documents are approved, detailed designs proceeds, finalizing all equipment material definitions. Minor pending issues may still be included at this stage. Issued for construction. These documents are ready for construction, so no pending issues are allowed in this version. As built. This is the final stage for the documentation of a construction project. These documents reflect changes made in the final installed version, as compared to the original design.